Alright, so now we're going to talk about converting to and from degrees and radians and graphing angles and writing the angle given the graph. So converting to degrees, I want my answer to be in degrees when I'm finished. And because this is in terms of pi, that means this one is in radians. So remember, I want to get rid of the radians. So I want those to be on the bottom, and I want to end up with degrees, so I want those to be on the top. And I know that there are 360 degrees in every circle. There are also 2 pi radians in every circle. So that's proportional. So now I'm just going to multiply straight across. And I get negative 7 times 360 is negative 2,520. And then I multiply 4 times 2, which is 8. Oh, I'm sorry, this is pi. And then 4 times 2, which is 8 pi. And then I reduce it. Pi over pi cancels. And then I would divide that negative 2,520 by 8. And I get 315. So radian canceled, pi canceled, and I get negative 315 excuse me, degrees. Same idea here. I've got degrees, and I want my final answer in radians. So when I convert, I would have radians on top. Oops. And degrees on the bottom. So that degrees will cancel degrees, and I end up with radians in my answer. And for every 2 pi radians, that's one time around the circle, there are 360 degrees, which is another time around the circle, or which is a time around the circle in degrees. So I multiply straight across. 2 times 70 is 140. And then I have 360 on the bottom. And so I would divide 140 by 360, turn the answer into a fraction, leave the pi there. So it would be 7 pi over 18. So this is having me graph these angles. So it's having me graph the 315 angle and the 70 degree angle. So let's start with the negative 315 degree angle. If this is negative, then it's going this direction. So this would be negative 90, negative 180, negative 270, and then this would be negative 360. So it's not going to make it one full time around because 315 is smaller than 360, but it's bigger than 270, so it would end up in this quadrant, which is quadrant 1. And so the starting point is always here. And then again, it's going to go this direction and end up in this quadrant. So to figure out how far in this quadrant it goes, I'm going to take this negative 315 and I'm going to take away negative 270 from it to find out how much is left that I still have to graph. And it's negative 45 degrees. So it'll be right there. And then I could label the 45 degrees on this side or the 45 degrees on this side. Doesn't matter. But this is what the angle looks like, and it stops here. There's nothing going past here, because otherwise that would go all the way back to negative 360. So now I need to graph 70 degrees. Okay, so now I'm going to graph 70 degrees. That's going the positive direction. So it starts here, and if it's a positive angle, then this is 0, positive 90, positive 180, positive 270, positive 360, but it's not going to get that far because it's not even going to get to 90. 70 is less than 90. So it would be, again, in this quadrant. And you can either write 70 degrees right here, or you can just write a 20 to show that that's how far left you have to get to 90. But then the angle needs to be right here to show that you didn't go past that. So coterminal, positive and negative coterminal angles. So a positive coterminal means they end up in the same spot. So like if I was to graph negative 275's angle, it would be, see here's negative 270, Negative 275 would be right here, and it would have started here and going in this direction. So I want to know another angle that would fall in this exact same spot, where this spot, this terminal side, would be the same. So like I could go one more time around, which would be another 360 degrees. So like I could go, I could go starting here and then pass it and do it again. So to figure out what that is, I would subtract 360 degrees. And that's negative 635 degrees. So that would be a negative coterminal angle. And then I could also, instead of going the negative direction, just gone this way and hit it the positive direction. So to figure out what that is, I would take negative 275, the one I started with, and add 360 to that. So like just going back this way, and that's 85 degrees. So I could add 360 to this, and I would get 85 degrees. So those are a positive and a negative coterminal angle. This one, you could do the same way. You could convert it to degrees and do it that way, or you could just say, okay, well, if it's 9 pi over 5, and I could go one time around the circle in the positive direction, I could just add 2 pi to it, because that's one time around the circle. So that's the same as adding 360 in degrees to it. So what I would do in my calculator is I would just take 9 over 5 and add 2, turn that into a fraction, and it's 19 pi over 5. So that's adding 2 pi. And then to go the negative direction, I would subtract 2 pi from the original. So I'm going to go back to 9 over 5 and add 2. And subtract 2. And I get negative 1/5 pi. So negative 1 pi over 5. So if it's in radians, you can keep it in radians. Just know that 360 around the circle and 2 pi around the circle. And you would add or subtract until you've got a positive. So let's say that I subtracted 2 pi from this, and I didn't get a negative number. That would still be a positive coterminal angle. I'd have to do it again. And we're going to skip to the end because that's where more of the degree measures are on there. So I'm trying to keep topics together. And then we'll go back to the next video will be graphing. All right, so you're going to tell me what this angle is. So I know that it's negative because it's going in this direction. So that makes this 0, negative 90, negative 180, negative 270, negative 360. So this is negative something smaller than 90 with 70 left over. So that would make this negative 20. Because one quadrant is 90 degrees. Like each of these are 90 degrees. So if this whole thing's 90, this piece is 70, then what's left would be negative 20. So the answer to this one is negative 20. This one's negative as well because it's going in this direction. So 0, negative 90, negative 180, negative 270, negative 360. And then it goes past that. So it goes all the way around one time to negative 360. So I know I have at least negative 360. And then it goes past that, but doesn't go all the way to 90. So if this whole thing is 90 degrees and what's left is 45, then what's here is 45. So I can just take away another 45 degrees to show me how far that is. And it is negative 405 degrees. It's a degree sign. The next two are positive, so they are going in the other direction. This is positive 90, positive 180, positive 270, positive 360. But then it goes past that. So that was just one time around. So I'm going to go ahead and add 90 to 360 because, again, each of these are 90. So 360 plus 90 puts me back at the top here at 450. And then it's still continuing. So plus another 90 to get me here. Puts me at 540. And then it's still continuing. So another 90. So this is 630. And then this whole thing is 90, but it doesn't go all the way back around here again. So if this whole thing is 90 and this piece is 80, then that makes this piece 10. So I would take that 630 that I was at from going 1, 2, almost 2 times around the circle, and add another 10 degrees to it, and the answer is 640 degrees. This one starts at 0, it's going the positive direction, so it's 90, 180, 270, and it doesn't go back to 360, but that's what that is. So it's got 90, 180, 270, and then 40 more. So I would just take 270 plus 40 to figure out how far that is, and that's 310 degrees.